Good morning. Good morning. Everybody hear me okay? All right. Looks like our webcast is on. So I'm just going to give a little introductory beginning to this seminar. So good morning to everyone here and to everyone on the webcast. And welcome to this presentation by Dr. Stephen Fennimore of UC Davis. I'll have Royce give a little more introduction of Dr. Fennimore's background in a minute. So this is the third in a series of presentations we've done on issues that we have with that are related to soil fumigant use in California. So this is very exciting to have this come up. And I'm Kevin Solari. I'm a program manager in the Worker Health and Safety branch, specifically in the Human Health Mitigation Program. And one of the components of our program is we provide outreach to our stakeholders in three main areas. One of them is farm worker community outreach on pesticide safety issues. Another is technical training to occupational pesticide users. And we also do outreach to on mitigation efforts that the Human Health Mitigation Program does. And one of the issues is soil fumigant use and on strawberries. And Royce Akanda of my staff has been instrumental in putting together all three of these seminars. So thank you, Royce, for doing a great job on this, providing the refreshments. Hope everybody's been taking part of that. And at this point, I'd like to introduce Royce to introduce Dr. Fennimore in his presentation.
Oh, thank you, Kevin. Good morning, everyone. Today's seminar is on transition from methyl bromide, I would say relief from methyl bromide to grow strawberries and other products. So our speaker is Steve Fennimore. Dr. Fennimore, he did his BS from the University of Oregon in 1977, and he did a master's from UC Davis in 1983. And Steve, he did a Ph.D. from Purdue University in 1997. He did some work with the chemical company Zenica, especially with the product development before joining at UC Davis. He has been with UC Davis since 1997, working on soil fumigant and other products to develop integrated pest management strategies for strawberries and vegetable crops. Here is Dr. Fennimore.
Okay, is this on? Can you hear me? Yeah. Great. Thank you for the invitation to speak to you. I have a couple of things to say as I begin. First, I've been in pest management since 1980, and I spent about 10 years in industry with what was ICI, then it became Zenica, and now it's Syngenta, and it didn't become Monsanto, but who knows what's happening next. So I've been in ag chem, and then I went back for a Ph.D. I've just been 18 years with UC Davis. Until that time, until I finally hit 15 years, people said I couldn't really keep a job because it seemed like I was around. What I wanted to, so I've been in pest management a long time. And I've come to realize in Salinas is really a hotbed of not just salads, but of integrated pest management. You know, in my discipline, I'm a weed scientist, focusing on weed control, but I work in a lot of different areas. There's a lot of hoopla over what's happened in Georgia with Roundup Ready technology in soybeans and cotton. And come on up, there's plenty of places to sit. Don't be shy. But there hasn't been the attention given to a place like Salinas. It's because people like Harry Agamalian 40 years did their homework and did a really good job of instilling in the growers how to manage weeds and other pests through integrated approaches. And it works. And so the quiet people, the people that do their job and go to work every day, don't get the attention. Salinas Valley does integrated pest management, and they do very, very well. So it's quite relevant. And what I'm going to present to you is the methyl bromide transitions, fumigants and non-fumigants, within the context of integrated pest management. I haven't seen that done, maybe you have, but to me it worked really well because I have a very healthy respect for that. The other thing I want to talk to you about and incorporate I need your support and everybody that might be listening. We are at the point where we are hiring some new people. So integrated pest management is relevant to this. The USDA, for example, and I'm based in Salinas, we don't have a UC field station in Salinas, in the Salinas Valley. I am very grateful for the fact that I can work with the USDA ARS, and I'm based there. And it's a good system. I've been there 18 years. My colleague, Krishna Subbarao, has been there since 1992. It's a good place to be. ARS is going to be hiring 2 new scientists. Sam Farr, the congressman, got some money. Strawberry Commission worked with them. And so we are at the basis of forming a new team. And what I really need your support on is getting a new UC extension specialist. I am an extension specialist. I'm not a campus-based professor. I have a research and extension appointment. We are would like to place a position in Salinas that's focused on strawberry. Hussein Ajwa, who is quite familiar to this agency, has retired a couple of years ago, and we are looking at trying to reform the team. So that's what's going on. I appreciate the chance to talk to you. So let's talk about the big picture. So generally, when you give a presentation, you should start from the very general aspect of it. So we have, in California, some very expensive land costs. We have labor shortages. We need crops that have very high return. I hear of land rents in Ventura County of $5,000 an acre for strawberries. Very great land there. Unfortunately, some of it's right next to a school. But to pay that kind of land rent, you can't get it producing dry beans and winter wheat. You need a high-value crop. You need raspberries, you need blackberries, you need strawberries. You need cut flowers. So fumigants cut flowers is a very, very difficult situation, and they're very dependent. And I've seen some fields in the Ventura area that are a mess because they haven't been able to fumigate. So back to regard to this point about a long-term plan, and you can laugh at the suggestion, but what we really need to do is get the politics out of the room, and we need to come up with a long-term plan. Because the reality is, if somebody comes to you guys and tells you that there's a short-term fix, something we can solve this problem in 2 or 3 or 4 years, show them the door, because they're not telling you the truth. The truth is, if we're going to create a truly non-fumigant system, we're going to have to breed strawberries that are much more resistant or much more tolerant to macrophyllum and verticillium and Phytophthora. It's just the truth, and that takes time. Breeding we're talking about a perennial crop, a vegetatively propagated crop. To do that, it's going to take quite a bit of time. We are making progress. We've hired Steve Knapp at exactly a year ago. We did the interviews, and he started the 1st of February. And he's a seasoned veteran. He has industry and academic background for a transition from a very rough situation we had prior to last year until now. He's definitely the right person for it. And so we've got a lot of things going on, a lot of challenges for the growers. We need to keep in mind that these guys need to pay their bills. They've got crop loans every year. They need to be able to pay their bills. So we need to focus on the long term. We need to put that together. we also need to keep in mind what the growers need. And that's why I work on fumigants as well, because chlorpicrin is a pretty good product. I know it causes a lot of problems to a lot of people, and you guys know much better than I do, but it's a good fumigant. And I've heard a few of the veterans say when I started that replacing chlorpicrin is going to be more difficult than replacing methyl bromide. I think they're probably right. So one of the things that we really have in common and really could benefit from a lot of collaboration and work with this agency is this idea of developing these non-fumigant strategies. So what I'm suggesting is that we need to form within the various strawberry production companies, within the various public and agencies, we need to develop a working team. And we need to put the egos and the politics outside. You can laugh, feel free. I know it's pretty naive, but we need to do this. And I want to do this because that's how we're going to get it done, is we're going to have to get the people and we're going to have to do it. We've made some progress, but there are no easy fixes. I mean, we've seen substrates. That was the answer in 2012. They're really expensive. They cost $20,000, $22,000 more than the cost of putting strawberries in. They work well in the Netherlands. They're very, very difficult. Then there's ASD. Is it the answer? Does it work every time, every place, like methyl bromide? No. I've seen it fail. I'm not sure what the consistency of it, but it works the majority of the time. There is no simple solution. Even the fumigants, the new fumigants, I'm going to talk to you a bit about DOMINUS, allyl isothiocyanate. It's not very clear that it's a real strong product. So we are in a crisis, and whether the crisis is, if you looked at those recommendations are, if you, for example, if a close family member passes away, your house burns down, some critical life event, you need to stop, take a deep breath, do what you need to do to get your life back in together. That's what we have to do. We are in a slow-moving crisis. And where we need to go, where the fundamental bedrock is IPM. That's where we start. Again, if somebody tells you they have a quick and easy answer, show them the door, because there isn't one. Pest management fundamentals. This is a review. This is a pesticide agency. You people have been trained on it. Just a reminder. Strategy. It's an action plan. Strategy is a much broader cut. Tactics. Chlorpicrin, use of chlorpicrin is a tactic. These are pest control methods. So strategies. There's prevention. That's what CDFA does a good job of doing, keeping pests out. Some of them get in. We've got some insect problems. But that's a classic example are the checkpoints coming into California. The management. This is really where the work is done in IPM. You have to, once the pest is established, it's slipped past the prevention, it needs to be managed by multiple tactics. The problem with methyl bromide is that and why we've had such a hard time getting rid of it, is that it is really a unique product, and we've been able to be lazy and discard. I mean, even with methyl bromide, the growers were pretty good about practicing IPM. But what I've come to realize, come to appreciate, is that with IPM, nature doesn't allow very many shortcuts. It primarily requires hard work. As the growers found out in Georgia, they're back hand weeding and cultivating cotton. They thought they had gotten rid of that back in the 70s. But You know what? By repeatedly using glyphosate, they created a real mess. And so they've had to dig out from that. So when we get lazy, if you like, and continue to do the same thing, that's a problem. Pest management eventually is going to catch up. In the case of methyl bromide, the product still works. It's a very good fumigant because of the vapor pressure of the product and the excellent dispersion you get. Just happens to be an ozone depleter and also happens to be very toxic, but you guys know about that. So, tactics. Some of the approaches to tactics, manipulation of the pest so it does not harm the crop, breeding for resistance. Manipulate the crop so that it tolerates the pest. Actually, that's where resistance breeding goes. Manipulate the environment. That would be like substrate production. So just prevention. This is something, I'm an extension specialist, and I give lots of talks to growers. And this is just a simple thing like cleaning off your equipment. Not particularly dramatic. It's very simple. Take a shovel, but the people I've seen that do a good job of managing the pests on their farm do that. Salinas Valley, by and large, is very clean. Pest manipulation, prevention. Virtually all of the strawberries in the Watsonville, Salinas area are rotated with lettuce, and we have a problem. Lettuce, strawberry tolerates, maybe 2 or 3 mycosclerotia per gram of soil, whereas lettuce tolerates 150. And here's verticillium in lettuce, and there's what it looks like in the roots. And so there's been some work to try to address this in rotational crops prior to strawberry, to try to keep the pests from reproducing, because with this level, if you have several acres, with this level of inoculum, you're creating a real mess for yourself. So with verticillium prevention in lettuce, there is Dan Chalemi with Driscoll's, came over from the USDA, really good scientist, very good grasp of pest management. He's jumped on this idea of trying to control verticillium in the lettuce. And what they've been doing is looking at fumigation. So they've been testing Dominus. I'm wondering why we don't maybe look at flaming. I visited a fellow by the name of Hank Poulsen in Denmark, and he's doing a lot of work with flaming on weeds. And one thing Frank was doing that I thought was really interesting is he's blending propane with oxygen, just much like a acetylene torch in a shop. And he's getting a much hotter flame. And I'd really like to try that on this crop termination, to try to see if we can kill a lot of these pathogens with a much hotter flame. You can do it with fumigants. The jury's still out. I asked Dan Chalemi for a verdict, and he says, give me some time. We're not ready to give a verdict on this. I'm going to talk to you a little bit about steam in a different context, but in this situation, where we would need to control the verticillium is very close to the soil surface. And so that would allow us to do a very fast pass through the field with steam. So there are chemical and non-chemical things to do, but we need to think outside the box and look at that. Another thing we've done, and I've been pestering the plant pathologists for years on this, is that we are essentially flying blind. We're treating fields. Traditional treatment might be 350 pounds of methyl bromide chlorpicrin. That's go back 20 years. That would be very common. The field's treated consistently. Whole field is fumigated at the same rate, but there's not a fumigant everywhere. If you go out and measure, and this is rather expensive, and this experiment needs to be done, and somebody needs to do the work, and somebody needs to fund it. So I'll drop that hint, but it's probably not going to be me because I'm really not qualified to do this. But there's not consistent pressure within a field. So why in the heck are we treating the whole field consistently? Well, one of the reasons is, I'm told by the pathologist, is that it's expensive. We're looking at about $100 A sample, that's to do one sample. So within an acre, how many samples do we need? Do we need 20? Do we need 1,000? We don't really know. We need to do that experiment. And I talked to Frank Martin. He's an ARS scientist in Salinas quite a bit about this. And the Australians have started to do some scouting in wheat for presence of diseases in the soil. And they've come up with a model for 2 or 3 diseases based on soil testing. Why don't we do that? Why don't we at least find out what it costs? And at some point, is it going to be cheaper? We've got a lot of, I know a startup company in Silicon Valley that's working on this. So is it possible to reduce the cost? Is it possible to increase the efficiency? Do we need to do it every year? And at some point, can we reduce fumigant use and apply the fumigant, instead of applying it across the field consistently, can we just apply it where we really need it? For example, here's an 80-acre block. And in that 80-acre block, and this is my story, so I'm going to make it up, we have 12 acres, that's 15% of that field, that has very, very severe pathogen pressure. It's a 9 out of 10. 10 is the worst. We have about 24 acres, or about 30% of the field, that's a 4. We better do something, but it's not as bad, not nearly as bad as this. And then we have over half the field, which has virtually no pressure. And so that's 44 acres. So here's the chlorpyrifos dose that we need. We probably ought to put 300 pounds to kill the verticillium in this area. It's no nonsense. We're going to use 3,600 pounds. In this area, we can get away with a minimal dose, 100 or 125 pounds. So for simplicity of math, that's about 2,400. So we're going to treat this field, and we don't even need to treat the rest of this. So we're going to put about 6,000 pounds. Whereas if we put 250, a little lower rate, that we're going to apply across the entire field, we're going to put 20,000 pounds on. So there's your difference. Why aren't we doing this? Why aren't we looking at that? We have the precision, the ability to control. Greg Brown and USDA and Sriti Upadhyaya with Ag Engineering at Davis did that in almonds. Why can't we do that in strawberries? We need to know it. If it's too expensive, we need to answer the question, can we do this? Because we're flying blind. So this is the paper I was talking about in Phytopathology by Poole, 2015. They used DNA soil testing to diagnose diseases in wheat. Different diseases, but it's a much less valuable crop. So at what point will the cost of testing be cheaper than the cost of fumigation? We need to know the answer to that question. Fumigation is pest manipulation. So I'll talk to you a little bit about some fumigation. This is some work. I've been doing work in flowers. I really like working with the flower growers. They don't get as much attention in this area, and it's very gratifying to work with them. These are some trials that we did at Milanos, which is in northern San Diego County, Carlsbad and Oceanside area. Extremely high value area. We tested at that site methyl bromide, pichlor 60, and then Dominus plus pic. This is a pre-formulated treatment that the Trical and Isagro put together. And then we had that at a total of 40 gallons per acre, Dominus at 40 gallons per acre, and then TRX, which they're not disclosing yet, so I can't tell you what the chemistry is there. We had that at 500 pounds, and then we had TRX 58 plus PIC. And then we had a smaller field, and we had those treatments there. Pichlor 60 is the standard, Dominus, and TRX 58, as well as an untreated control. So here are some results on pathogen control at Carlsbad. This is Fusarium, and I'm grateful for the assistance from Jim Garrick, who is a plant pathologist with USDA in Parlier, California. So here's the treatments that I just reviewed with you. We've got data on Fusarium and PYTHIUM. We've got pre-samples through the field. So this is prior to the fumigation, and then this is after the fumigation. This is why, of course, you know the growers really like methyl bromide. And Pichlor 60 did a really good job too. So we started out with 183, we ended up with nothing. A very high pressure in the Pichlor 60 plots, and they were completely controlled. Here's Dominus, and Dominus plus chloropicrin. It didn't get everything. Here is TRX 58, bit disappointing. Here's PYTHIUM, which PYTHIUM I generally find is among the easier pathogens to control. And again, methyl bromide and Pichlor 60 did a good job. Dominus didn't really do much to it, unless it had chloropicrin in it. And then here's a TRX, which looked promising on PYTHIUM. This is weed control. Cheryl Willen, the IPM advisor down in San Diego, gathered this data. They had 2 crops in the field. They had a ranunculus and delphinium. And so here's the methyl bromide standard. Methyl bromide does not kill all the weeds. You don't get 100% control. So there's the standard. Pichlor 60 did a very good job. Dominus did not. TRX 50 did respectable, and then there's the control. And then here's the time. We generally do economic analysis, and so we in addition to the yield, we try to take account of the fact about how much time. As we've talked about already, there's a tremendous labor shortage, and so people that we can allow the grower to free up from hand weeding and move them to more important and more lucrative tasks like picking flowers or picking strawberries, they like that. So basically, there's what methyl bromide does. It had, even then, it had a lot of weeds. That's almost 70 hours per acre. That's a lot. But there's the control. 266 hours is a lot. So there's your treatment range. Okay, this is the San Luis Rey site, this is near the San Luis Rey Mission, right at the edge of Camp Pendleton, for those who might know that area. They had Fusarium data and PYTHIUM data from Jim Garrick again. Am I off? Oh, okay. We didn't get all the PYTHIUM. We had some pretty severe pressure there, and the only treatment that really performed very well was the TRX treatment. There is a non-treated control. Lots of Fusarium at this site, an old flower site. There's PYTHIUM. Basically everything worked on the PYTHIUM. And then here's the weeding time, which was quite a bit less weedy. And there's the Pichlor 60, Dominus did better, and TRX did better at this site. There's the control. And then here's the yield. There was quite a bit of variation. This is the number of delphinium stems, not that much difference. Moving to strawberries, which is probably of maybe more interest, more acreage. So this is a trial we did in Salinas last fall. We looked at K-Pam at a couple of rates, basically a low and a high rate, a Dominus at 20 and 40 gallons per acre. Pichlor 60 at a fairly low rate. Pichlor 60 followed by, these are sequential applications, which are very, very common. Excuse me if I'm telling what you guys know, I feel like I'm preaching to a very knowledgeable group, but this is what we did. Pichlor 60 followed by K-Pam in sequence, about separation of about 4 days apart. Pichlor 60 followed by Dominus. K-Pam followed by Dominus. This is a sort of a creative treatment. We're, of course, afraid of losing chloropicrin, and we're looking at alternatives to that. And that was the reason for that particular treatment. So, nematodes. Had some real plant pathologists. I'm not a plant pathologist. We had Becky Westerdahl, who did the nematode testing. Frank Martin did the PYTHIUM work, and then Steve Koike did the VERTICILLIUM work that I'm going to show you here. So this is not mine. I just was coordinator of the trial. So nematodes, these are the numbers of nematode, live nematodes for 50 grams of soil. There's what K-Pam, well, first I should show you what the non-treated control. We had about 1,800 alive in there. K-Pam knocked it down but didn't completely reduce it. Disappointing with DOMINUS. Chlorpicrin, which is not a nematicide, and generally all the nematologists will point that out, but it did a very good job in this situation, followed by K-Pam. PIC followed by DOMINUS also did a good job. And then the combination of K-Pam and DOMINUS did a good job. PYTHIUM, basically the K-Pam alone and the DOMINUS, very, very similar to the nematodes. Very disappointing results there. PIC, chlorpicrin, continues to be a strong player. And then here's the VERTICILLIUM data. We had 40 microexposure per gram of soil. That's a very hot soil. It only takes 2 or 3 to kill a strawberry plant. So basically, the K-Pam knocked it down into probably barely tolerable range. DOMINUS did not. This is too much. PIC followed by K-Pam and DOMINUS did an excellent job. So here's the weed control and the fruit yield. Not a lot of disease pressure. This, I should say, these are artificial. What we do is these are bioassays. We take a sample of maybe 100 grams of soil, and we put them in mesh bags and we bury them in the soil at in this case, 8 and 18 inches deep in the soil. Generally, what I look at when I'm looking at a fruit yield, I compare a known standard, which that would be this case. I compare that to the non-treated control. So we're only getting about 4,000 pounds increase. That tells me that there wasn't a tremendous amount of pressure in this site. So that's why we have to do a lot of studies. So basically what this shows is virtually all of the fumigant treatments did a reasonably good job on the weeds compared to that kind of pressure. So we also buried weed seed, and these are percent viable. And so virtually all of fumigants did a reasonably good job on the weed seed. We had burning nettle, we had prostrate knotweed, common purslane, and nutsedge. Nutsedge is a perennial. And when you kill a nutsedge tuber, you're killing, you have to kill, it's a tuber, so like potatoes, and it has about 6 to 8 eyes on each tuber, and you have to kill them all. Otherwise, the one that survives, that sprout, is going to sprout, and it's going to successfully, unless it's buried too deep, successfully emerge. So weed control is probably not going to be the challenge. So with DOMINUS, it appears to be weak on nematodes and PYTHIUM, not something we like. Nematodes is not a real big target in strawberries because they don't raise sugar beets on the coast anymore, and so the populations are much diminished or rarely found. PYTHIUM is just about everywhere. You have to control PYTHIUM, otherwise you're going to see some yield reduction. You got to control VERTICILLIUM. It does appear to have some activity on it. Disappointing. It's a highly immobile compound. I guess the company has come to talk to you guys, and so you can see things like the vapor pressure. Methyl bromide vapor pressure is over 1,400. So it's a very good fumigant, disperses, whereas DOMINUS is 4, like 1, 2, 3, 4. It's actually 3.7, depending on the temperature. So it's stuff that's not very mobile. I keep hearing from the company that, yeah, they're going to come up with a new agent to disperse. So I'm waiting to see that. People have tried that in Telone for years in Florida because they would like to do effective drip fumigation applications in Florida. They've got sand and they have difficulty getting lateral dispersion. So, show me. K-Pam, it didn't control nematodes very well. It suppresses, but it's not a knockout treatment. If we have to rely on the K-Pam, Vapam, Sectagon treatments as a standalone fumigant, we're going to probably see increased disease pressure. So, I'm going to talk to you a bit about steam. We've been working on steam since about 2007. Got some funding from your agency. I appreciate that. This is a unit which is owned by Ryder. A group of you saw it in 2013. It's a tractor towed, propane fired. I'll show you a little bit of data from that. We've got a new unit, and I'll show you some pictures of it. I'll show you a movie. So, steam. I have never presented it as a standalone treatment for treating 40,000 acres of strawberries and 5,000 acres of field-grown cut flowers every year. That's not going to happen. But if you go back to that slide and talk about rational use of fumigants, the role for steam is a fairly consistent product, consistent treatment, and used judiciously in the places where you need good pest control and where you have high pressure. Steam can kill verticillium. It kills most of the pests. It doesn't disperse. Steam only goes where you place it, where you physically place it. So you have to inject it with steel. It is a standalone non-fumigant treatment. It's not easy, and we are working on that. But one thing that we forget about, and it's a bit of a cultural issue, is we are used to, and I'm not telling you anything you don't know, you're a pesticide regulatory agency. You deal with chemical companies. What incentive? So chemical companies, they have a patent, they own a label, they have an incentive to protect their product, to spend money on R&D to protect their product. So if I'm going to go in the steam application business, or I'm going to go into anaerobic soil disinfestation, or I'm a consultant that's promoting substrate, now how do I get paid? I can't patent that process, probably any of those processes, unless I come up with a really whiz-bang technology. So how does that happen? That is a difficult, but I think it's a fascinating topic to talk about, because we sort of are stuck. We would love, and I've talked to people in the home pest management, everybody, the consumers, and I would love to hear your war stories. Consumers they have cockroaches in their house, their ants or whatever. They would love to have green treatments, but they also want the cockroaches dead. I mean, who wants them in your pantry? Who wants them in your baby's room, your children's rooms? So there's sort of contradictions, or there are gaps in what we want and what we need. The same thing exists in the field. How do we get across that? And it's a very interesting topic to me, because we have to deal with that. If we want to promote non-pesticidal technology, we have to have an answer to that, for that. So this is what we did with steam. This was sponsored by Propane Council, a lot of contribution by Ryder and the Driscoll companies. We basically had a bed shaper that we injected steam into the soil. So we've evaluated that, and actually it's still running over on Carrollton Road in Watsonville. Ryder is still using it. They're using it in another crop besides strawberries. So they like it. It works. Gives them an edge. So this is what we did with that machine in the soil, measuring the temperature. You know, there are all kinds of petitions for methyl bromide with the extension of the use of methyl bromide. to MTOC for the continued use of the critical use exemption. They say that repeatedly that steam doesn't work. Steam works. It's just not a drop-in replacement. Drop-in replacement, silver bullet if you like, is a terrible concept. It's easy to say, yeah, we use methyl bromide, it was a one-stop treatment. We want another treatment like methyl iodide. You guys have seen methyl iodide. And you see what happened to it. It's a pretty good treatment, but you see what happens. There is no such thing as a silver bullet. We need to forget about that. It's not compatible with pest management. We need multiple treatments, one of which is steam. This is what that machine that Ryder has can do. This is the soil temperature in Fahrenheit, what you want. 70 degrees Fahrenheit is 158. 70 degrees centigrade is 158 Fahrenheit. And this is what we did. In about 90 seconds, we heated the soil from 30. So we go from 60 Fahrenheit to 160 in about 90 seconds. That's what this is showing. This is the bottom of the treatment. This is the bottom edge of the treatment. So it's just barely making it to about 140, 138 Fahrenheit. This is what we can do. Good weed control and good PYTHIUM control. So that the blue bar is pre-treatment and the red is after. So here's what steam is doing. We've been looking at steam with additives like mustard seed meal. It's a nice treatment. Works well together. Macrofumina, these are counts at the end of the season. Here's a non-treated control. About 33% of the plants are dying of macrofumina. Nasty disease. Steam, didn't get them all, but a significant reduction in steam plus mustard meal, about the same. Here's the yields. This bar, the amber bar, is chlorpicrin, Pichlor 60 standard, which has given you about 54, 55,000 pounds of fruit from Albion. The non-treated control was about 25, so we were doubling the yield with steam. There's steam plus mustard meal. We looked at the consistency over time across trials, and steam was approximately, in terms of consistency, approximately the same as chlorpicrin. It's fairly consistent. You have to do a good job of getting the steam in the soil, but if you do, it works about like fumigants. We have data, and I'm not showing you everything because I've got several publications, and I can give you the list if you want to look at them. We have controlled verticillium, macrofumina, PYTHIUM, and a number of weed species, and the yields are comparable. So again, I keep beating this drum about you have to have some place for it to go. You create a treatment, you have to have a place for it to go. You have to have a reason for somebody to pay a business to do the work. So I work with Rachel Goodyear from Davis, and an ag economist who keeps me honest, and I work with engineers. I am not an engineer, I'm not an economist. You have to recognize your limitations. So what we have is, and this is a real farm in Ventura County. It's 80 acres, you can crop 72 of it. The rest of it are parking lots and roads and irrigation pumps and irrigation infrastructure. 65, due to the fact that there's a school off on this end in Ventura, you cannot fumigate this block. There's another thing. The regulators, the ag commissioners, draw concentric circles. Farmers farm in rectangles. So there's an overlapping buffer zone in this area, and so this entire block, 7 acres, it cannot be fumigated. It's just not practical to do maybe a little corner here. They just leave the whole thing out. So this is what steam is needed for. One of the things, there are more reasons, is to treat these areas. And so pretend I'm a fumigation company. I come in and say, you know, Mr. or Mrs. Grower, I'm going to for this much money, I'm going to treat this whole farm. And just leave it to me. I'll steam what I can't fumigate, and I'll get permission from the ag commissioner to fumigate the rest. So they have 7 acres. So the fumigant costs on Pichlor 60 is, $1,900, $2,000. So they got a bill for fumigants of $123,500. The steam costs $5,000 an acre. We can talk about that. That's a guesstimate. I don't know what the cost is going to be because nobody's doing it yet. So that's going to be $35,000. So the total cost of treating this farm, the contract is going to be for $158,000. So I'm a grower. I want to know, am I going to make money on doing this? Am I better off just making that a parking lot? Which is what growers have said. The heck with it. I can't fumigate it. I'm not going to farm it. I'll just make it a parking lot, or I'll let a vegetable grower have it that doesn't have to fumigate. So by planting that, and based on yields from other locations, I can make almost $130,000 if I steam that piece. That's the net returns above costs. If I don't steam it, I'm going to make $16,000 off of that area. So, you know what? I'm going to steam it. So on the previous unit, we used about 812, 813 gallons per acre. That's based on 70% coverage. I'll show you what the new one does. That was based on a cost last October, a year ago, of $1.56. I paid last week, I paid between $1.44 and $1.52 a gallon. And it's been as low as $1.30 based on Bassel's from Hollister. So, oh boy, I've not got as much time as I need, or I've got too much to talk about. So what, we could eventually go to natural gas. There's no shortage of things to do. Natural gas costs, I'm told by the engineers, would be quite a bit less. But the infrastructure is in place for propane. A lot easier to use propane than methane or natural gas. So this is what we built with funding from DPR. Thank you very much. We tried to do our best with the funding available. This is from Johnson's in Cedar Rapids, Iowa. And this has been built by Valley Fabrication in Salinas. There's one of the machinists right there. That's Valley Fabrication in the back. A great shop. They can build anything except maybe an engine. They're really good. This is a tube, a direct fire. This is an engine. The sole purpose of that engine is to power a fan, a blower. This is not a choo-choo train steam engine. This is a blower, a rather sophisticated unit. It's a direct fire steam generator. It has a burner right there, and the air and the flame go down. This is a ceramic tube. It's actually made out of alumina, called refractory, and the steam is made right there. It blows on through, and I will show you a little clip of this. Actually, I have a better one, so I'm going to break and show you the full length. Since you paid for it, I'm going to show you what you got for your money. Okay, I lost that. Okay, there it is. The tractor that's towing it. We're moving slow. This is a dispense research station in Salinas. Water, that's Dan Hodell from Johnson. He came and spent 10 days with us teaching us how to use the thing. That's where the water comes through that reel. There's the tractor, and there's where the propane comes from. I like clips. So these are numbers hot off the press. We're treating 100% of the field, burning 862 gallons of propane. Those are the costs. So this is the actual cost for treating that is about $1,287. Now Rachel has cautioned me. Rachel Goodhue, economics. We need machine costs. And we need labor costs. So we need to include all that. This is not the total cost. So that's what we've got. We've got some work to do on that machine to scale it up, but that's what we've done as of last week. We last operated it on Thursday. So when we are ready, I'll let you guys know. You're welcome to come down. I don't think we can fit it into your lot here up front. It won't. The ground speed, well, what we were running there was about 9-10 feet per minute. So it's quite slow. We are losing a lot of heat, and that's what we need to work on. We're pretty confident we can go about 20 feet per minute. So it's not fast. It's not a fast treatment. What our goal is to be able to treat between 1 and 2 acres a day. I mean, obviously, we'd like to treat 2 acres a day. But the fumigation rigs from TriCal, they're treating, an acre in 30 minutes. We're not going to get to that. But we're not using steam to compete with fumigants. We want to use this where we can't fumigate. So you guys tell me what percentage of the area are we going to be able to fumigate in 5 years? Well, you're not going to be able to tell me that because you don't know, I don't know. So it's basically preparing for the future. So I'm not sure how far I can go into this, but I will keep moving. Anaerobic soil disinfestation basically involves the good treatment. Went 5 minutes. Should I stop and take questions? I can basically just stop. Yeah. I'll give this in about 2 minutes, and then what's that? Yeah, however we want to use it. So basically, ASD is the best treatment. The one I know that's most consistent is you use about 9 tons per acre of rice bran, which is 6% nitrogen. So there's a lot of nitrogen. It's hard to understand what's going on, and I'll let others. So here's a commercial scale application, spreading it simply with a manure spreader. The growers have been doing this. We tried molasses, that's Joji Muramoto, I've worked with in the past, putting in molasses and we're injecting it through drip line. That didn't work for some reason. Theoretically, a carbon source should work. In Japan, they use ethanol, but they have much warmer conditions. And this picture is at Salinas. In Ventura, it seems to work better. ASD, there is some. This was a really nasty buffer zone where there was some very high verticillium pressure. And so that's what ASD was doing. We're combining it with solarization, and that's the untreated, which I don't have to tell you, they don't look good. These are some yield comparisons. This is from Watsonville. This is the untreated control. This is what I like to see in a trial. The big difference, about almost a 40% increase in yield due to the fumigant, standard in this case. And basically with steam and mustard meal and ASD with mustard meal matching the fumigant. So this is what we want to see with ASD. The problem, well, here's a TCR where I brought a group of you, or a group of you came down 2 years ago. This is a recent trial we have at TCR, the company ranch of Driscoll's, and there's a control. This has macrophamina in it, and then there's steam. This is another site, Fuji Ranch, just south of Salinas, about 3 miles, and here is steam side by side with ASD. Which do you like better? This is the problem with ASD. Is it consistent? Does it work every time? What we see with steam, and I guess this is an advertisement, so you guys can do what you want with this information. But a couple of growers I work with on steam have said, this was taken last month. September is when they make the money. Steam holds up. It holds up into September. The plants in ASD look great in May, but they kind of poop out. Why? I don't know. It's complicated. We need to breed. We need to breed for resistance. And you know what? I guess I'm going to run out of time. spent too much time on each individual slide. So again, we need to work DPR, we need to work together. I mean, we need to talk. We need to collaborate. Not asking for money, I'm asking for your time and your input. We have a strawberry work group within UC Extension, and we are writing position descriptions, and we're trying to hire the next round of people. Things have been the budget's been bad. You guys, I know all about that. We've had a big turnover in the generation. We need to hire new people. Let's do this right. Let's get the people we need to develop an integrated strawberry management program. We're on the same side. I think we want the same thing. I want to see California's strawberry industry stable on into the future. They're good, they're great people. We need to talk to them together. We need to collaborate together. And I'm convinced, and give me 25 years, we'll solve the problem. I won't be around for 25 years, but that's my message to you. Please, let's work together.